Good day, class. In our previous video about Gaussian elimination method, we answered this question to this point, which is actually the last point, the final bus stop for Gaussian elimination method. For Gaussian elimination method, you're supposed to stop at a point where all the elements on the major diagonal to be 1, while the elements below the major diagonal to be 0, of which we obtained that and we stopped there and we got all our answers. So Gauss-Jordan here is an extension of the Gaussian elimination method. So this is where we stopped for Gaussian elimination method. Now for Gauss-Jordan, you're supposed to have 0 here, 0 here, 0 here, and 0 here, so that the answer should be clearly indicated. Now to do that, what can we do to -1, -2 here will be 0? We will say that -2 plus 2, it will give you 0. So now you will say that row 1 plus 2 times row 2 in such a way that if we say that -2 plus 2 times 1 here, this will give us -2 plus 2, which is 0. So this will play through. So now we have the second row and the third row will stand as 0, 1, 0, dot, dot, -2, 0, 0, 1, dot, dot, 3. So now this will still stand as 1. This is now 0. So now for this one here, we are going to have row 1 here, which is 1 plus 2 times the corresponding element here for row 2, which is 0. This will give us 1 plus 2 times 0 is 0. This will give us 1. It will give us 1 here. So now for this one here, row 1, we have 8 plus 2 times the corresponding element on row 2. The corresponding element on row 2 is -2. This will give us 8. 2 times -2 is -4. This will give us 4. So what we have here is now 4. Now the next step is for us to have 0 here. So what can we do to 1 to make it 0? If we say 1 minus 1, it will give us what? 0. So to get 0 here, we will say that row 1 minus row 2. Row 2 is 0. It will still give you 1. So it cannot play through. You will say that row 1 minus row 3. Because we don't have to multiply anything here. Because if we multiply anything with 1 times 1 is still 1. So you just say that row 1 minus row 2 in such a way that we will say that row 2 will stand. Row 3 will also stand. And this first element too will stand. So now, even if it is not standing, since we said that row 1 minus row 2, row 1 here, 1 minus 0, 1. 0 minus 0, 0. 1 minus 1, 0. 4 minus 3, 1. So we have all our answers. So this one too is the final point. This is the last point for Gauss-Jordan. Using Gauss-Jordan, the moment you have all the elements on the major diagonal as 1, 1, 1, you stop. And all the elements below the major diagonal as 0, 0, 0, and above are 0, 0, 0, you stop. So just get the differences. For Gaussian elimination method, you stop here. For Gauss-Jordan, you extend further to a point where even all the elements above the major diagonal 2 will be 0, 0, 0, 0. This one is the end point of Gauss-Jordan. Why this one is Gaussian elimination. So that is what you're supposed to get clear, and it will help you. So now here, it is clear that our x is equal to 1, y is equal to -2, z is equal to 3. You can use any method at all, and you get the same thing to confirm the answers. So now, x is equal to 1, y is equal to -2, z is equal to 3. So for Gauss-Jordan, you don't have to do backward substitution. All the answers will be clear in the final matrix. No need for backward substitution. Thank you so much for watching this video. Please like, share, and comment for more videos.